Hello children, we are doing class 11 physics chapter 2 units and measurement. In that one, based on the dimension analysis, we are starting the topic. Assuming that the frequency nu of a vibrating string depends upon the load F, that is the force applied, load F applied, that is length of the string L and mass per unit length small letter m. Prove that nu is the frequency equal to 1 by 2L into root of F by M. So first I'll just tell you the dimensional formula. Dimensional formula for frequency. Frequency nu, I'm just giving an introduction about this sum. Frequency nu is 1 by t, 1 by time period actually. So dimensional formula for the frequency nu will be, dimensional formula for frequency nu will be for nu, that will be equal to t raised to 1 it is, when you take to numerator, t raised to minus 1. But in terms of, we will write in terms of m raised to 0, L raised to 0, t raised to minus 1. Now we want to do the dimensional formula for force. Force is actually mass into acceleration, but acceleration is change in velocity by time. So dimensional formula for velocity is L t raised to minus 1. And dimensional formula for acceleration is change in velocity divided by time, that is Lt raised to minus 2. So dimensional formula for force will be, dimensional formula for force will be F equal to mlt raised to minus 2. How we are getting that one? So it is actually because I'll write here force F equal to ma. Unit of dimension formula for mass is m. Dimension formula for acceleration is Lt raised to minus 2. From there you will get the dimension formula for force actually. Then again mass. Here this m is representing actually the given force by m. This m is representing mass per unit length. So mass per unit length m equal to, in this question only, m is representing mass per unit length. M equal to mass per unit length, it is mass per unit length dimensional formula. So its dimensional formula will be equal to mass dimensional formula equal to small letter m is mass by length, I'll write mass by length. Now dimensional formula for m. Dimensional formula for m is for small letter m. Dimensional formula for small letter m is here mass by length it is. So mass, length is in the denominator m by L. It is ml raised to minus 1. This one is only for this sum, mass per unit length, that is why. Otherwise, mass dimension formula is capital M only. Now we'll start the sum actually. So this is just an introduction about this sum. Now we'll start the real sum. So here in this one, now we are starting the sum. In that sum we'll write, assuming that frequency nu of a vibrating string depends upon the load F. So frequency nu depends upon means proportional to. Depends upon means proportional to. Frequency nu proportional to, which thing actually the force applied F. Then again length of the string L. And again mass per unit length M. This one I will just put in a box. Now here we'll replace that one by equal, proportionality sign will replace by equal to sign. So at that time we have to add the constant of proportionality. So it will be nu equal to k into F, L and M. We'll give the power because we don't know force how many times, length how many times and mass per unit length how many times. So we'll write F raised to A, L raised to B, M raised to C. We'll take this one as equation number 1. Now we are comparing. We have to write the dimension formula for frequency. You know the dimension formula for frequency nu, that is t raised to minus 1. I'll write that one in terms of mlt raised to minus 1. Dimension formula I am representing now. mlt raised to minus 1. So m raised to 0, l raised to 0. Because only t raised to minus 1 is the real dimension formula for frequency nu. So m 0 times and l 0 times equal to dimension formula for force. Constant of proportionality has no dimension formula. So we will neglect that one. Now here dimension formula for force, that is m l t raised to minus 2 and its power is a. Then next one L. L is L only and its power is b. Next one mass per unit length. So it will be m L raised to minus 1. The power is c. Power is b. And this one's power is a. Now we'll open the bracket. That means we'll apply the powers for each term inside the bracket. So m raised to a, L raised to a. This one is an explanation. Directly you can go to the next collecting of terms. So L raised to a, t raised to minus 2a. Then next one will be L raised to b. Next one m raised to c, L raised to minus 1c. M raised to c, L raised to minus 1c. Powers. Now here we'll connect the terms with m. So m raised to, if the bases are same, you study the add the powers. So bases, m collecting the terms of m. So bases are m and m, we'll add the powers of m, that is a plus c. Again L, terms containing L I am collecting to the L raised to a plus b minus 1c. And now collecting the terms with t. T, only one term is the t raised to minus 2a. We are comparing it with m raised to 0, L raised to 0, t raised to minus 1. L raised to 0, t raised to minus 1. Now I will write comparing the powers of m, l and t. So I am writing now comparing the powers. Powers of, first one m. When we will compare the powers of m, you will get 0 equal to a plus c. By comparing the powers of m, you will get 0 equal to a plus c. On the other way we will write, that will be better. So a plus c equal to 0, comparing the powers of m. m. So a plus c equal to 0. Equation number 2. Now comparing the powers of L. So it will be a plus b minus 1c equal to 0. Equation number 3. Next one, comparing the powers of t. That is, it will be minus 2a equal to minus 1. Minus 1 is the power of t. Equation number 4 I am writing, or directly you can solve it. Now minus into minus will become plus, minus will be cancelled. You will get 2a equal to 1. If 2a equal to 1, what will be a? A will be 1 by 2. So you got the value of a. Now after getting the value of a, we can substitute the value of a in equation number 2. I am just writing equation number 5. So substituting, otherwise a equal to half is also enough. Substituting a equal to half in equation number 2. When you substitute a equal to half in equation number 2, it will be half plus c equal to 0. So what will be c equal to? Minus half. So you got c also, and now a also you got. A also you got. A and c now you got. Now after getting the value of a and c, we will substitute a equal to half. So I am writing substitute a equal to half and c equal to minus half in equation number 3. Because we want to find out unknown quantity b. Now here we will substitute, rubbing this one. Now when you substitute that value of A and C in equation number 3, so A is half plus B minus C is minus half equal to 0. So it will be half plus B plus half equal to 0. You know that half plus half is 1. Although some finding difficulty, I'll collect half and half. Common denominator is 2. Add the numerator. If the denominators are same, add the numerator. So 1 plus 1 by 2 plus B equal to 0. 1 plus 1 is 2. 2 by 2 plus B equal to 0. If 2 by 2 plus B equal to 0, we'll get B equal to 1 plus B equal to 0. That is B equal to minus 1. So you got B equal to minus 1. Now substituting the value of A, B and C in equation number 1. So A is actually now half, B is minus 1 and C is minus half. Now we are substituting that one in equation number 1. Substitute. Just write this equation number 1 equal to K into F raised to A, L raised to B, M raised to C. Now substituting in equation, substituting A equal to half, B equal to minus 1 and C equal to minus half in equation number 1. When you substitute that one, you will get nu equal to K into F raised to, in the place of A, otherwise I'll write once more, F raised to A, L raised to B, M raised to C. Once more I just wrote equation number 1, I am substituting. So it will be equal to nu equal to K into, in the place of F you can force F, will keep like that, and its power is A is equal to half and power of L, that is B actually, B is minus 1 and power of M is C is minus half. Now the terms having negative power will take to the denominator, so it will become K into F raised to half divided by terms having negative power are L raised to minus 1 when you take to numerator. When you take from numerator to denominator, it will become L raised to plus 1 and C raised to minus half. Again we are taking to the denominator, so it will become C raised to plus half. Plus half is representing the power square root actually. X raised to half is actually root x. So we'll write the terms containing the power half in the root sign. So it will be nu equal to K into 1 by L into root of F by C. Now, not C, it is M actually, sorry, it is M. Not C, mass it is. F by M. Now we got 1 by L into root of F by M. Now what is needed? 1/2 we need. So we'll write that one as, we'll assume that one when K equal to, because we want to prove that is half. So when K equal to half, frequency nu will be 1 by 2 into 1 by L into root of F by M. So 1 by 2 into L is 2L. So it will be 1 by 2L into root of F by M is the frequency of the vibrating string. Frequency of the vibrating string is 1 by 2L into F by M. This one is the derivation. Now we'll go to question number 2.